everyone. This is episode number 8. Okay, remember there is was of episode number 7 in English, but episode number 6 was skipped in English because episode number 5 English was same as in episode number 6 Italian. So it had to be skipped in terms of numbers, but in terms of content, both of them are the same. That's the first thing that, because I was asked this question, what happened to episode number 6 English? It was skipped because 5 and 6 Italian are the same, have the same content. Just to keep everything in sync, I prefer starting both of them from 7. And now, when I finish one, I finish the other one. I do not add anything extra. It's always the same. So they are always in sync. Before, I was putting things extra. I don't know why I was doing it, to be honest. I should have always kept them in sync. But it seems that in the English version, I was doing more than in the Italian version. So the Italian version took longer, while the English version was shorter, because instead of maybe 2 hours, I was doing 2 hours and a half. So that's the main reason why they became offset from each other. Okay, so as always, I need to start with the thanks. First of all, I'd like to thank Fabio Ciucci for letting me and to stream his book basically. It's quite an honor for me to do this, given how famous this book is in Italian. Please note that Discord is the main chat channel for this series. Okay, so and all the links are there. Okay, so as you know, we started chapter 3 and we spoke about the copper, and I explained the copper, what is it, and the instructions of the copper, etc. So chapter 3 had some theory in the beginning, but then we started doing the exercises, and we did exercise number 1, and we are going to do exercise number 2 in a minute. Please note that there are lots of examples to do for this chapter, so we will not be able to do them all. I'm going to show you how many there are. So all those that start with 3, okay, and these are all examples in chapter 3, okay. So we have quite a long way to go through all the examples, and you start understanding how to program the copper and create some effects, and some of these effects are quite interesting. Okay, back to the book. So this chapter, we are on page 37. We have page 37 to finish. Okay, page 38. Okay, and then page 39. Okay, and after that is all the exercises. There's nothing else, no more theory. It's just going through one exercise after the other and following the exercise book. So let's start. So we did exercise number 1. As you can see, it's in green. That's a distinction for me to tell me when it's an exercise, when it's just text to read. So green is always text, is an exercise, and yellow is always text to read, basically. I have other colors, but they are very rare shown on the in the book as my comments. So as I told you, the kickstart, the ROMs inside your Amiga, which are called kickstart, has got a number of libraries into them. Okay, one of them is the exec library, another one is the DOS library, another one is the graphics library. Okay, and then there are other libraries that normally are in the libs directory on your hard disk or your floppy drive, which the Amiga will know. Oh, this library is not on in Kickstart, so okay, I will have to look at it in the libs directory, and this happens automatically without you knowing. Okay, so that's how that's how libraries are loaded and used on the Amiga. Okay. Um, Also remember that we use JSR, not BSR, to call OS libraries. Um, we You cannot use BSR to call libraries because, of course, BSR is limited how far it can travel, while JSR can go anywhere in the memory of the Amiga. Okay, remember BSR is only can only go 32767 to 32768. Sorry, 32768 to 32767. So minus and plus, of course. Um, so that's the limit of BSR. Here we have a small little program of what we're trying to build. So we basically, okay, load the exec base, okay, disable multitasking, call our program, okay, whatever the program is, we jump to subroutine to our program, and then we return back and we re-enable multitasking. So basically, the first line 1 and line 2, okay, actually line 2 kills the operating system, line 4 returns the operating system alive. So restores it back. Okay, and what happens in the middle is our program. Okay, of course that's in a simple way of doing it. We are going to expand a bit on that. Every kickstart routine will be at a different address. Okay, so also um, the kickstart ROM jumps, okay, will vary between one OS to the other. Um, let's say kill, sorry, um, disable multitasking. With Kickstart 3.1, it will be a call, let's say, at a certain number, at a certain address. But with Kickstart um, 1.3, it will be at a different address. So this is why it's not a good idea to call uh, the libraries directly, but use the jumps. Okay. Um, the libraries, some of them are copied into memory. Okay, so I don't want to exclude that this happens also sometimes on the Kickstart. I'm not sure 100%. I think some of it might be copied, but I'm not sure. Um, so I don't want to confuse you, but for sure, the jump to subroutines can be in a different position. Okay, so please use the jump table that is provided by the OS or by Kickstart in this case, and not try to call them directly. Um, I've seen some of our sources, I'm talking Phase 101 sources, there are some calls to routines directly on the Kickstart. But at that time, we thought that Kickstart 1.3 or 1.2 was God, and nobody else will have something as different, which is wrong. Um, so that code will not work, uh, most probably on a different Kickstart. Although I said the routines will be differently in memory, the jumps to subroutine will always be the same. Okay, so the offset will always be the same because it's a jump and an address, a jump and an address. Those, if you build a table, will always occur at the same place. Okay, in terms of calling them relatively as we do. we need also, from that small program that I just covered, we need also a way of storing the OS copy list, okay, before we start our own program and start manipulating the copy list. So that is one of the tasks that we need to do. As I said, we need a way of storing the copy list that the OS uses. So that is available through the graphics library, which is also in Kickstart. Okay. Hence, we have this code here. Okay. So what is this code doing? Here we're opening the graphics library. So before we can even get to the copper, we need to open the graphics library. So before we were using the exec base to kill the multitasking of the Amiga. Now we need the graphics library, we need to open it because the exec library is always open. It's the only library that is always open, but the graphics library is not open. You have to open it. So we open the graphics library and then we store the base address of the graphics library. Further down, we're going to see that we get how to get the copy list address that we have that the OS is using. So let's go through this code. It's quite the normal way. So we get the exec base into A6. We load the graphics library line 2 into the graphics library name into A1. Remember, the graphics library name is like this, is written like this. Okay, and then we call the library open library. Okay, in fact, okay, you cannot understand Italian, but you can see it means open library. -198 is open library. Once we open the library, we are storing, if the library opening the library was successful, we are storing the 0, which is the value that we have, which is the GFX base, into the GFX base address. So we are storing the value here so that we can use it at a later date. So how do we do the libraries for the Amiga? How do we know which library to call and how do we call them? And that is done by going to our famous books, Amiga books, okay, with this link, which I shared several times now, where there is the Amiga docs. So you need to learn how to use it. And in includes and docs, okay, because this is for OS 3.5 and 3.9. Eventually it became 3.9. So we need till 3.1, Kickstart 3.1 or Workbench 3.1, we need to use this one. So it includes and docs. We need to go to references, and there are two: function offsets and structure functions. Function offsets is to get the library number jump address that we need to do. Okay, for now I'm going to explain. And then each library has also a structure. A structure is a list of data that tells something, and for example one of them is the copy list address, where it is for the OS, and that we get it in structure offsets. Okay, and then if we want information on a library function, what it does, let's say on the exec, and we want to say open library. Okay, here's an explanation of what the open library does. So just remember those three. The rest will come at a later stage. Those three are the most important to learn how to call libraries on the Amiga. So just to recap, I went to the function offsets. Okay, I'm going to look for graphics library now. Okay, there you go, graphics library. and then we need to find sorry, um, because we are opening a library, so that is in exec. So we need to find open library. There you go. And what does it say? It's old open library, to be honest. That's the one that we are calling. What does it say? Minus 198. And that is, if you recall, that is the value, the book, not. That is the value that he's using, minus 198. Okay, hex. So that is how you get um, the reference, the jump to the reference to one of the system libraries. Um, so here now we have the exec base, sorry, the GFX base. Okay, so here he's going to say that we need now from the GFX base, we need the copper address, okay, that the OS is using. Hence, you can see that we are doing the same thing as up here, okay, till line 8, okay, okay, till line 7, we are doing exactly the same as before. But line 8, what we are doing, we're moving also the 0 into A6 because we are going to get something from the GFX base, which is the couple list. Okay, okay, that the OS uses, and that is offset 26 from A6. And once we get it, we store it into the in our memory location old copper. So back to the what I was showing, which is now we need structures, okay, structures, and we find graphics, GFX, okay, GFX base, okay. So now we got the GFX base, and from the base we need the copper in it, and there you go, copper in it is 26. So 26 comma a bracket A6, because that 26 is the offset from where the GFX base is. So that's why we loaded A6 with the value of the GFX base. Okay, so remember, we got the GFX base, we put that in A6, and using this addressing mode, okay, we went offset of 26 from the base address of the GFX library, and we stored that in old copper. So we now have saved the OS copper list where it is. Okay, that's all that that code does. Now we need a way, okay? So we have saved the OS copper list, but now we need a way of telling the copper, the Amiga, hey, this is where our copper list is, and then please initialize it. Start executing our copper list. So there are two registers, which is DFF080, okay, and DFF088, okay. One is where you tell it, hey, this is the address where our copper list is, okay, and the other one, the FF088, okay, you just can move any number in it, okay, any number. As soon as you put some number in it, it will start initializing the copper with the address that we put in 080, okay. That's how it works. In fact, here you can all understand the word write. That's what it does. Okay, so I explained the copper list, how to set it and how to initialize it. After we've done this, we execute our program. Remember that small little program that we had before, where it said we do something, then we execute our program, and then we do something. After we have executed our program, we need to restore back the couple list. We need to enable multitasking, and then we need to basically close the graphics library and restore back to the OS, given we return back to the OS. So here is our program, okay, that I was talking about. So line 1, we are moving the exec base into A6. Then we are calling, okay, disable multitasking, okay, -78 is disable multitasking. Then we are loading, okay, the GFX name into A1. You know, this is the GFX name into A1. Okay, this is the address of where it starts into A1. And then we call, remember, -198 open library. Okay, so far you've seen this. Then we store the GFX base that we get when we open the library into our GFX base address. So we store it here. Okay, then we get the couple list of the OS and we store it here at line 35. After that, okay, remember what I said. We tell the Amiga, hey, our couple list is here. So here is a label called couple list, and this is our couple list. Okay, these are couple list instructions. So we are telling the Amiga, this is where it starts. This is the address where it starts. And then we are moving something, whatever that is, into DFF088. We are initializing the couple list. Okay, so basically our couple list starts executing. Now remember, the couple list is drawn 50 times per second on the screen. Okay, so you have a couple list, it starts executing. Once it finishes, it returns back to the top of the screen and starts doing it again. Okay, and it does this 50 times per second on the screen of this repetition. This is for PAL systems. If it's an NTSC system, it will do it 60 times per second. Okay? So once we passed the couple list and we initialized doing the couple list, we just wait for the mouse button to be pressed. So remember, this is always the same routine that we've been seeing since day one of this book, to wait for the mouse button to be pressed, okay, the left mouse button to be pressed. When it is pressed, okay, so after the routine has been, after we have finished looking into our own couple list, admiring it on the screen, okay, so all it does is telling, okay, no bit planes, okay, set the background to black, in the middle of the screen set it to blue, okay, and then end the couple list. Okay, that's what it does. When we stopped admiring this, we press the left mouse button and we exit from our little program, and we restore back, okay, the couple list. So basically, we restore back what we saved of the OS into the FF080, and we initialize it again. So basically, we tell the OS, okay, you can have back your couple list. We re-enable multitasking, okay, and we close the GFX library and we return back to the OS. Okay, simple. Okay, now for your info, and this is going to happen many times, this part till here, okay, till line 13 is going to be seen many times in our programs. So I will be skipping that, and I will not be explaining that again because it's a repetition, no? And same thing from after the from line number 18. This is our exit routine. Okay, so I will not be doing that. All I will be doing is executing, saying what's happening here into the middle. Okay, just to make things clearer. This is, let's say, our simple little program that allows us to display a couple list. I'm just going through my notes to make sure that I mentioned everything. Okay. Remember, here we are setting 0-bit planes, so we don't have any images, we don't have any display. We are just using the raster lines to display colors. Okay. And trust me, you can display the all 4096 colors of the Amiga with with using just color index 0, which happens to be the background color. Okay. So there we set it to black, then we wait middle of the screen, and we change the color to blue. Okay. So we arrived into example 3b. Okay, so let's do example 3b. I'm just going to prepare to go into the book of the exercises 3b, but first let's jump on the Amiga. So assemble J, and there you go. That's what we just covered. Top of the screen is black, bottom half is blue. That's all, and we are admiring that screen. Okay, not doing nothing special except doing all this. Once we press the left mouse button, we exit. So it's a copy of what we just did. However, the book doesn't end there. So let's bring back the book. So as you can see, okay, the book, these are the same routines, the same things that we just did. Okay, wait for mouse button and then we exit the library. There is one thing that needs to be explained, is the section. Okay, so he explains it. Let me go through my notes to make sure that um, uh, I'm not skipping anything. Okay, that's done. That's done. It's done. That's done. That's done. And that's done. Okay, so now he starts explaining the section. Remember, the Amiga has two types of memory, fast mem and chip mem. So basically it has two types of memory, chip and fast mem. And fast mem is memory that is not used by the custom chips. Chip mem is memory used by the custom chips, where graphics and sound goes. Okay, so basically the chip mem, okay, anything that is graphics, anything that is sound needs to be loaded in memory where chip mem is memory shared, used by the custom chips. Okay, so we have the famous section where we tell the Amiga where our data, let's say that graphics and sound, will go. So that is what section does. So here he has some examples. I'm going to go into more detail than this in a minute, but for now let's follow the book exactly. So section is written section, then you say, you give it a name, whatever name you want to say, and then you have data or code. because you can also have code in chipmem, no? So if it's data, you write data underscore C. The underscore C means it's chiprem, okay? If you don't specify don't specify the underscore C, okay, like in the second example, then it can go into chipmem or fastmem, depends on what type of memory you have. I mean, a basic A500 has only got chipmem, a basic A600 has got only chipmem, but if you add the expansion card, then you have fastmem, okay? And that is the difference between them. Um, Same thing. You have two more lines. Code underscore C is for code that goes into chipmem, and code without anything is selected as chip and fast. Now, this is for Tresham assembler or ASIM1, the old version. ASIM Pro, okay, requires underscore P, but takes also data. So I'm just going to bring the manual of ASIM1. We find the section. Of course, it doesn't find that. Let's find it. There you go. We need to make it one page, fit one full page, and then expand it width, and yeah, it's showing blank, but it will come. I think this is a bug in, come on, in the new there you go, it's coming in the new Acrobat reader. So as you can see, section takes a name and a type. The type can be data, code, data, or storage which is not initialized. So for now, don't bother with BSS, okay? Just consider the first two. Now, code and data can be a C. You can add a C under it. You can add a P. Is there something that is missing there? Yeah, I thought so. You can see, look, data underscore P, data underscore C, and data underscore F. Okay, so if it's underscore F, means always place the code in fast memory. If it's underscore C, always place the data in chip memory. If it's underscore P, if there is available fast mem, put it in fast mem. If it's not, put it in chip mem. Okay, so first, that's why it's called public memory, but public memory means first go to fast mem. If you don't have fast mem, go to chip mem. Same as there is for data, there is for code. Okay, so you can have code underscore P, data, code underscore C, and code underscore F. Okay, the DevPack manual on page 131 from yesterday. I remember the page, so don't think I know the book by heart, which I don't. 131. This is the section page. Let's make it big. Okay, so the same thing, section, some name, and type. And type, they are all here. Okay, so code underscore F, score underscore C. It takes also code underscore P for public, but like the old version, to be compatible, I think they also accept code by itself, which it means same like code underscore P. Okay, same is for data, and also same is for storage, but uninitialized storage, but let's not go there yet. So these these 6, okay, is what you need to keep in mind. Let's continue with the book. So we did that. Next one. It has a problem, the Acrobat Reader of refresh, I think. But yeah. Here he gives a simple program with using different sections. Okay, so at the start we place our code. You can see moves here, and we put section and underscore code. So basically we're telling it put it either chip mem or fast mem. Okay, as you can see the note here, you can all read that. Then we have a data section. Okay, and we're specifying this data section to be in chip mem. Okay, then we have another data section for music, and we're also specifying chip mem. I will come later why to do that. And then we have another data section, okay, which is also chip mem, okay, and we are putting some data. Why he's using multiple sections for data that needs to go in chip mem instead of specifying it once, because he did not need to do this line. He could have removed this line, and this line he could have removed it also, because they will go into chip mem anyway. But the more bigger the block is, the more it's difficult for the OS to find you a block of RAM that is so big. If you say I want a block of RAM which is chip mem, which is 50k, it's easier than telling it, hey, I have all the graphics here, all the music here, and altogether they occupy 300k, okay, of chip mem. Okay, can you find me 300k of chip mem? That is um, quite quite a big thing. Okay, so he is explaining why here it's better to look 300k of chip mem is difficult than if you had to ask 50k of chip mem. So yeah, it's one of those things. Uh, Here he covers an addressing mode that he didn't cover in chapter 2, and he left it, and I told you that he left one addressing mode out, and that is the PC relative addressing mode. The PC relative addressing mode has got an advantage that is shorter, okay, because it's done relatively. So if you had to type um, move long something without the PC, okay, it will take 10 bytes. It's here actually, sorry. I was pointing here, but it's here. It's this line, okay? This is 10 bytes, okay? But if you write it with the PC, it will take 8 bytes, okay? So that's an advantage. We save 2 bytes each time when we use the PC relative addressing mode. The only issue with the PC relative addressing mode is that you can only go be far away -32768 and +32768. Okay, so there is that limitation. So you need to make sure that the code is close to you. Okay. The other disadvantage is that if you create code sections, okay, uh, you cannot use PC relative to jump to another section because you do not know where that section is. Okay, so it could be 32k further away, and if it's 32k further away, then it will not work. Hence, the assembler will give you an error if you try to reference code which belongs to another section. Um, so section something, my code, comma code underscore C or P or F, uh, it won't work. Okay, so this I've done. This I've done where it says it only takes 8 bytes. okay, instead of 10 bytes. Okay, and here it's saying that it does 32768 and 327. So here the relativeness is that. But try to use it as much as possible when loading references, okay, in your code. As you can see here, he's using it several times. Um, so try to add label open bracket PC, so PC relative addressing mode, uh, because it helps you in having the code for, shorter, saving memory. And yeah, the Amiga, you can say, have a lot of memory in a certain way, but you still run out of memory because graphics and sound takes a lot of memory. So saving 2 bytes each time is quite a lot. Remember also the way we specify color. So remember that there's also always a 0. So 0 and RGB. And RGB is red, green, blue. And each value is from 0 to F. Okay, so 16. And if each one of them is 16, can have a value, a different value, a different intensity of 16. Then we have 16 times 16 times 16, okay, red, green, blue, so 16 times 16, which makes it the 4096 colors that we get on the Amiga. I mean, I'm talking on a standard Amiga, not an AGA Amiga, okay? So I just covered that. Here, he has given us a copy list, okay, that I'm going to show you, where it starts with lots of blues and then does a copper bar of red and then changes to blue. So this is, okay, this is listing 3B1. So we will read file 3B1, okay, assemble. So just one thing to make you aware, these are exercises that he expects us to write and code and then try out. I did these for you. So this example 3B1 is not on the diskettes that you download from RamJam, okay? It is not there. But I did it for you as it will take for ages to do the book. And that is not the scope. I mean, I do not want to do the book forever. I would like to finish it and make you all Amiga coders. So we are in chapter 3, and each chapter roughly takes either 2 sessions or 3 sessions. It depends. So far, further down, they will even take longer. So I hope that by the end of the year we would have finished the book. Okay, doing one chapter each week. Sorry, doing one chapter at least each month. We should finish the book by then, hopefully. So I see 1 year of this happening, basically. But I will be happy when I finish the book because I think I would have there will be more Amiga coders. Um, and hopefully the year after I will see more games of for the Amiga, which I love. So if we execute it, there you go. As I told you, there is blue at the top with our, of course I do not have mouse, so I cannot really show you with the mouse pointer, but at the top you can see the shades of blue, okay? Then we have a copper bar, all the colors of shades of red all together. Then we have black, and then we have the blue again at the bottom, okay? So that is a simple copper list, okay, that we expanded or enhanced, um, never-ending course. Unfortunately, I mean, unfortunately and fortunately, the course is very long. I mean, the book is quite big. I mean, it has 1,700, nearly 800 pages without the exam. I mean, it has got the documentation, the you know the talking. Then it has got the examples, but and that is with the examples by itself, it is 1,900. If you do the exercises, it goes close. I bet it goes close to 3,000 pages. So eventually, I will share all this code, of course. Um, but how to say, it's um, it's not yet. I want you guys to get the book. I mean, for the Italians, get the book. For the English, I mean, you still have to get the book. But try the examples, manipulate the examples. Try. I mean, you don't need to understand the what the book says, or you can use Google to translate it, but you don't really need to because it's explained already to you. So all you need to do is try the examples and modify the examples and try different things, and you should have a different result, a quite interesting result of all this. So I do suggest that you get the book. We did. Um, let's go back to the book. So we did this exercise here with this couple list, and you saw the effect. That's all it's doing. It's displaying a different couple list, okay, from the previous example. Now, so we finished actually 3B, yeah, 3B, and we are going to start 3C, but 3C, uh, 3C, there is some more reading to do. So let's go back. So we did 3B and we are here now. We're going to do, so this one should bring us to exercise 3C. Okay, and from then on, after 3C, you can see we finished 3C. It's saying, did you finish 3C? Then you start doing all the other exercises. Now 3C has several exercises in it, so we will actually finish 3C only. I mean 3C and its exercises. So we will never start the others. Because it's quite long. So here he's explaining, okay, what I explained earlier, that the screen is drawn 50 times per second. Okay, where is he? Frank, remember this. For the Commodore 64, it's the same thing. The screen is drawn 50 times per second. And hence, okay, we sync with the vertical blank. I mean, the vertical blank is called the vertical blank because it's from when the screen ends and so nothing continues to be drawn. Screen ends and goes back to zero. That moment from end to zero is called the vertical blank. But you can call the vertical blank in a way, okay, not to, because there might be somebody that jumps on me and tell me that is not the vertical blank. Yes, okay, but you can wait on any position on the screen to update your screen, okay? And normally we do it when we finish the last line of our screen, and normally that is position 250. After 250 on the Commodore 64 it's 250, okay? On the Amiga it's a bit different, but let's for now say it's 250. And when we do raster line 250, we can start, when we reach raster line 250, we can start executing the code, our code. Also remember that for NTSC it is 60 lines per second, not 50. So we did that. You know where the raster line is by checking, by reading what's in DFF 006, which is indicated here. Okay? DFF 006 tells us which raster line we are. So if we want to wait for raster line 250, we just need to read it and continue read it till we arrive to in raster line 250, and then we know that we have arrived the line that we wanted, and we can start executing our code. So as you can see here, we are waiting for line to 50 to 40, sorry, FO is to 40. Okay, and if we are not in line to 40, we go back. So this is a simple example of how we need to wait for a line, a raster line. On the Commodore 64, hint for Frank is you have registered D012, I believe, hex register D012, where you read either D012 or D011. One of them is the high bit, so I might be, I don't want to confuse you, but one of those two. You read the register. If we are at line 250, bang, we have done, we have arrived where we want. And that is how to sync one frame at a time. Okay, so we do 50 frames per second and not more, which is quite important to have everything synced. So once we wait, okay, so here we have a routine that waits for a particular line, raster line, which we are saying to 40. Then we check if the mouse button is pressed. Sorry, this is waiting for the license, so it's a copy of this one. I was going to confuse you. So here we are waiting for line to 40. Then we execute our routine, okay? And once we execute our routine, we return, because our routine is very small, okay, we do another check. So did we press the mouse button? So first we wait at line till line to 40. And if not, if we haven't reached line to 40, we go back. If we reach line to 40, we execute our routine. Now, our routine is very small. Okay, so because it's very small and it can execute in a few, remember the Amiga has got also the X of a raster line. So it can execute in a shorter line, okay? So the line starts at position 7 and ends at position FF, let's say, till it moves from line 7 to line FF. It can execute lots of instruction. If our code is small, then it is executed more than once. So what we need to do is, so we executed our routine and then we check. So we executed our routine, then once we executed our routine, we check for our mouse button, okay? And if our mouse button is not pressed, we return back to the loop, okay? So that's basically it. Let's see what he says about line 240. Yeah, we have something that is executed every frame, and this happens on line 240, and it is executed 50 times a second. I mean, I'm repeating this because it's quite important. It's how you sync things. Okay, so here he explains how the raster line works on the DV. So it's a line drawing, okay? It starts from top left hand corner and goes down, moves to the right, goes down one line, then continues, goes to the right, and continues, and does it so fast that you don't see it being drawn on the screen. Okay, that's what the old TVs used to do, and that is still what computers do in a way. So now we are going to do example 3C. So I'm going to change to the book. And we go here, we're going to do example 3C. So remember, the first part is always the same. Okay, we disabled multitasking, we open the graphics library, got the base, and we initialized our couple list. That is always the same. Okay, here we are comparing if we reach line 255. If we reach line 255, we go back. If we haven't, sorry, if we reached, we um, um, test if we have pressed, okay, the right mouse button. If we have pressed the right mouse button, we do something, okay, we do something here. If not, we jump. But if we did, we do something, okay. If we did press it, we do this routine, move the copper. If we didn't, okay, we jump to aspetta, which is here, okay. Aspetta, what it does is waits again for line 255. Why? It's simple, because as I said, this routine is so short, okay, it's so short that from when the start of the beginning of the line till the end of the line, it would have been executed. And because of that, we will be on the same line after we have executed the same instruction. So it will be redrawn again. So this is to avoid doing the same thing twice in one frame. Okay, that's why it's being checked. Um, then we check if we pressed, I'm going to say when we press the right mouse button what it does, but for now I'm just explaining the main loop, okay, what it does. Um, then we test for the left mouse button. If we press the left mouse button, we restore. This is known already, I explained it. We restore the system to its original state by restoring the couple list, enable multitasking, and closing the GFX library. So you know all that. So movie copper, all it does, it's add one to where barra is. So barra, we are adding one to this value here. Okay, so from 79 it becomes 80 hex, then 81, then 82, and 83, and that is it. When it becomes FF, it resets to 0 and it becomes 0 0, and you will notice that soon. So let's execute it. And basically we end up with the screen all red in the end. So the Amiga, read 3C, assemble, execute. So as you see, we have a couple list which says the top part of the screen is blue, the bottom part is red. When we press the right mouse button, you're going to see the red moving down because we're adding one to it. But when it reaches 255, it goes to the top and the screen remains red because we have everything red then. So as you can see, you saw it being increased and then we went red, and every time it is red now because we changed uh, the position to be red everywhere. Okay, okay, so we continue with the book. So we did this, what it does. Now he's going to give us some exercises. Of course, he likes to keep us occupied. So he's explaining that this part of the code um, waits for the left mouse. I think I've done that. No, it's did I go back? Yeah, I went back. Sorry. We need to be here. So he has told us, okay, to do this exercise, and this exercise means that we rename, put a remark for BSR movie copper, and we have at quick.b always here. So basically, what is going to happen is we're going to add one always like before, okay, to barra, okay, to that location that where there was 79. But then when it resets to 0, okay, it starts again from top and goes down. So let's do that example. Now, yesterday I had problems with this in this state because the code, when I was doing it, I changed hard drives. I got a bigger hard drives, and I think the code was not copied properly, and I have an older version or something like that. So, and I don't think I saved it yesterday after I did it for the Italian side. So, let's see. Read 3C1, 3C1. Let's see what it does. But at least today I know what I need to do. Okay, so we press the right mouse button, it should start going down, and it went up and it stays red. Same as before, nothing changes because all we did is move the code that we had into the BSR. Okay, so just to, we had, where was the routine? We had a routine. Aspetta, where is it? There it is. Okay. No. So we edit it here, but where is the aspect that's down here? My God, it's in front of my eyes, and I'm not doing it. So basically, okay, we had the code before that jumped to to do something, but we removed it, and now we have at quick.b, which is exactly the same as before. Okay, it doesn't do anything, nothing changes in the code. It starts from line 79, where the red starts, goes down, and then turns everything to red. But we don't do the JSR that we had here. So I'm just going to remind you what has changed, because so here, okay, we removed the branch to subroutine, okay, after testing for the mouse, and we edit this one, the, the add quick. But if you had to check what movie copper was, so if we go back and we check movie copper, what it was, okay, movie copper was add quick dot byte immediate one barra. So all we did is move this, remove the BSR, and move this line up into the main code. That's what we did. So this is to show that nothing changes, it's still the same thing. Okay, if we do not check, if we had to, I mean, he's saying here, okay, if we had to skip the compare, okay, this line, this one, where we're checking again, are we still on line 255? Okay, so here we check for line 255 and we execute our code, but since it's so quick, it will still be on the same line. So if we had to remove that, this line, this compare, okay, and we are still on the same line, it will be executed twice. So that's not a good idea. Okay, so that's why we have the check there, which I already had I had already explained. Okay, what else are we going to do? Okay, so now we are going to hear what he's saying. Instead of having barra, okay, where the label was, and we change this value, we're going to change this value, okay, where the 600 is. And here is how the code should look, which is this part, this code. Okay, so look, barra was up here and we were changing the 79. We put a remark, we put a comment in front of it, and now we are going to change where the color is, and we have a dot word. Okay, so let's actually, there are two examples. One is dot byte and one is dot word. So let's in fact look, here is saying dot word, and there is also dot byte. So I'm going to do c3 underscore 2. Okay, exercise c3 underscore 2. So read 3c underscore 2, 3c underscore 2. Okay, assemble it, j, and this time, as you see, we are changing because we are doing at um, changing the color, and we are working on 1 byte. We are changing the illumination of of the color. Okay, I'm going to show you what the code does, because although everything is the same, but and we are doing the add 1 comma barra. Okay, so we're adding 1 to barra. So let's find barra where it is. So barra is here. Remember, we put a comment to barra. We were before changing this byte where there is 79, and now we are changing this byte. Remember, there's a 0 here. Okay, so this is a byte, and because it's a word, and we are changing this. Okay, so we are changing the intensity of the red each time, so that's why we see it glowing. Okay, um, so that was exercise 3c2. Let's continue with the book, and this time he's going to do word instead of, so he's telling us to change it to word. Okay, so we've done 3c2, and now let's do 3c3. So 3c3, basically 3c3, what is different, and you're going to see. First, I'm going to show you what happens when I press the right mouse button. You're seeing all the colors of the Amiga now. Now it's doing it so fast you cannot see them. Okay, um, but every time I stop the mouse, okay, you're going to see a different color. It's going through all 4096 colors, okay, of the Amiga. It's it does it so fast it's impossible to catch it. Okay, but why it's doing it? It's very simple. Before we were doing, remember, it was add quick. Okay, it was add quick dot byte. Okay, now we are doing add dot word. So we are working on a word. So down below where we had barra, okay, remember, here's a 0. Okay, but now we are changing, we're adding 1 to these 2 bytes. Okay, remember, we're working on a word, so this goes to 601, 602. So it starts with blue, and then from blue it goes to adding green, and then red goes up 1 by 1, and then again we start adding blue, etc, etc, etc. So we continue to do that. Okay, and we will be able to cycle through all 4096 colors. But as I said, it does it so fast it's impossible to see them. That's basically it, what there is to it. Nothing changed from the code except that we are doing add dot word. That's all that was changed. Okay, let's see. Let's see where we need to continue with the book. Okay, we're going to do 3C, okay? And this time, this exercise is quite simple. It's comparing where it should uh, restart, basically. So far we haven't seen that. So, as you're going to see, this is going to go down, okay? It does a compare and then stops, okay? I know there's a sudden move. Just ignore it for now. I do not want to go into the detail of that. But we're doing a check, and when we reach a certain position, that's where it ends, okay? And that's what the code does. So if we go here, okay, our routine, okay, that is being executed when we reach line 255 is doing, okay, have we arrived at line 3C, sorry, AC? Okay, if we arrived, then exit basically. If we didn't, add one, okay? So you do a compare, and if we are where we want to be, then we do not need to add another one and we exit the routine. And that's what we are doing. Okay? Oof, that was so if you notice, okay, I'm just going to go um, what we have before. If you notice, nothing changed. Okay, we are opening the library, the GFX library, storing the GFX base. We are just checking for line 255. We are checking if we press the right mouse button. If we did, we go to our move copper, okay, this line 33, and then we check, are we still on the same line? If we are, we wait, and that's basically it. It's not doing anything else, and then we, of course, we exit by pressing the left mouse button and return back to the OS. So there you go. We did that. So now, knowing that I have done 3C2, okay, we need to do 3C2 underscore 1. Okay, for the same example, if we assemble it and we execute it, this time, and I forgot what this one does. Hold on, I need to be there. It does the same thing, and with I think there's a change in the code, but it still does the same thing. Okay, here. We are waiting at a different position instead of CA. We were waiting at C6. We can maybe change it to, I don't know. Let's do it did 0, for example. And let's see what we start with barra. Oops, sorry. I pressed the help by mistake. So we start at 5.9, and we should, when we reach the 0, we should stop. Okay, so we should see it going a bit further down now through the screen. Okay, we start at top, press the right mouse button, we go down, and that is it. Somehow it's also jumping here, and that is there must be something that is telling it to jump. So if we start at 5.9, let's do 4.9.4C. Well, let's do, we cannot do more than 4. We can do 3C. Let's put it this way. I know that the screen starts at 2C, so assemble. So we must be quite starting from the top. As you can see, there's little blue, and then once we arrive at a certain point, it just goes bang to the bottom. I think we are executing the routine once anyway, so I'm just going to make a check. Um, ah, I mean, I wouldn't be surprised because the routine is so short that we are still on the same line. So I'm just going to, come on, where are we? Here. So why the cursor is not moving to where I want it? So this is strange. Ah, okay, let's exit and let's start again. It's like it's got corrupted for some reason, so it it's really corrupted. Yeah, for some reason it got corrupted, even the Amiga. So let's reset it. Yesterday I didn't need to reboot my Amiga, but today for some reason it needs to. To be honest, I was using it before today, so I might have corrupted it before I actually started the stream, and then it did that. I was doing some things on it, and I should have rebooted it because I was doing assembly. Yeah, now it's fine. So it was corrupted for some reason. Um, okay, so let's so we changed it to the 0 there, and down further down we should have 3C. So we start at 3C and we should arrive to the 0. But what I'm going to do, uh, I'm going to copy this. Okay. Okay, so we have it twice now. So we are waiting twice if we are on line 255, because I'm suspecting that it is being executed twice. So let's see if we go down. It still did the same thing. So there's something wrong. I'm not liking that part that jumps, but anyway, I'm being picky to be honest. Because if I start debugging the code, then it's a different story, and all he wanted us to do is have a check where we reach a certain location, and if we reach a certain location, we just stop basically, and that is what we are doing here when we reach the 0, which we are never reaching, but um, we are reaching 7F, I think, or something like that, according to what is there. But let's assuming that we are reaching the 0. It's done. Let's say it's my fault. I didn't do the exercise properly, and I need to look into it. I mean, yesterday I just didn't go into the detail of it, so yeah, it is what it is. As long as we understand the concept, we don't need to really go into the detail of why. It's just a simple example. Um, anyway, so we have, I think, let's see if I did. Let's see if so we did this. Look, we arrived to FC, and then if we haven't arrived, we add one. So that's what he's telling us. And we did this compare I. So it's also a quick. Yeah, hold on. That's why it was not. That's the difference. So I left it at compare I. Wait, hold on. You can use compare I, but you're doing a compare byte. So let's do this. Let's remove it as because at quick can only do a certain amount of. That's why. Yeah, we were using at quick. At quick can only do a certain amount of additions. Then it goes to it sets the high bit. So we shouldn't be using at quick. And that he wrote a note actually that will have like a bug, and I just ignored it. So yeah, so that's what we needed to do basically. To arrive where we needed to. Okay, so let's go back to the book. That's why we were seeing all the jump. And this is, let's see. Yeah, this is where I arrived yesterday in the English version. So the English version was maybe, sorry, the Italian version was maybe a little bit longer than the Italian version, but I'm ending it. I'm ending the English version same as we end the uh, as I in the same place where I ended the Italian version, um, because it makes sense. No, I was creating problems for myself before. Thank you very much for the follow. Thank you very much for your participation, and I hope you enjoyed this session. Thank you very much. Bye bye.